Today's legacy data platforms slow innovation and delay decisions. Modernizing these platforms is essential to unlock real-time insights, enhance agility, and drive business growth. It's not just a tech upgrade, it's a transformation that powers smarter, faster, and more collaborative, data-driven organizations. So before we dive in, I'll provide a quick intro about myself. My name is Ron Lesteve, and I'm a data and analytics leader with about 18 years of experience. I've led data platform modernizations at BP, Anheuser-Busch, Geico, Dell, JP Morgan Chase, Bank of America, and many more. I've got certifications from Microsoft Azure, Databricks, Snowflake, and Scrum Alliance. I've authored 4 books for O'Reilly Media and A-Press publications, and I've written about 115 articles for MS SQL Tips. In this session, we'll explore how organizations are transforming their data and analytics platforms to meet modern business demands. We'll cover challenges faced by traditional data and analytics platforms, the evolution journey of Microsoft's data platforms from on-premises systems to cloud-native SaaS solutions, how modern unified platforms like Databricks and Microsoft Fabric unlock new value, a deep dive into Microsoft Fabric's architecture, compute engines, and domain-driven CI/CD approach, key considerations in choosing the right modern data platform, whether it's Snowflake, Databricks, or Fabric, real-world examples including MLOps, Fabric Data Mesh, and unified PaaS and SaaS platforms, step-by-step guidance on a Fabric migration roadmap, and lessons learned from implementations. By the end, you'll have a clearer picture of the path to modern, scalable, and AI-enabled data analytics infrastructure. So let's get started. Traditional data and analytics platforms have long been the backbone of business intelligence, but as data volumes exploded and business needs grew more complex, these legacy systems quickly became obstacles instead of enablers. Here are some of the challenges that I personally noticed. One major challenge was the complexity of infrastructure management. Manual setup of networks, patching, scaling, backups, and disaster recovery created heavy operational overhead and increased downtime risks. Performance was another bottleneck. During peak workloads, platforms would slow down considerably, frustrating users and delaying critical insights. Storage limitations and rising costs forced compromises, limiting data retention and scalability, which in turn constrained historical analysis and decision-making. Security and governance were manually intensive, increasing risk and administrative burden without much automation or centralized control. Plus, these platforms lacked native real-time processing and AI/ML capabilities, preventing timely insights and modern analytics automation. Finally, fragmented data silos and complex integrations slowed development and made collaboration difficult, delaying time to market. All these pain points illustrate why organizations, including myself, have been motivated to modernize, to reduce complexity, boost agility, lower costs, and unlock real-time intelligence that drives competitive advantage. The centralized versus decentralized dilemma is yet another challenge that organizations face. The diagram on the left depicts centralized enterprise BI, which is IT-owned BI with a center of excellence team that builds and publishes enterprise-grade models, reports, and more to various departments through Power BI Fabric workspaces. They're typically published in Power BI apps and are read-only to the rest of the organization. Downstream business consumers and analytics teams can consume the published read-only artifacts as a managed self-service. This approach provides great governance and standardization from the central BI Center of Excellence, but comes at the cost of speed and potentially depth of insight and detailed domain-oriented analytics. The diagram on the right, on the other hand, represents departmental BI. When BI is decentralized as part of the business analytics division, each of these new teams would be responsible for their focus areas. While this seems like a great way to provide deep domain expertise to the business and speed of delivery, the pitfall is that the BI Center of Excellence has completely been dissolved with this approach, and each siloed team is left to apply its own standards, governance, integrity, and administration. Now, this can result in some issues, especially if no distinction has been made regarding the analyst versus developer roles. This diagram illustrates a large-scale Azure MLOps platform supporting hundreds of data science teams and thousands of models in production. Core components like Azure ML and model registry can be complemented or replaced by Databricks and MLflow, for example. Typically, a data scientist requests an experimentation environment via a ticketing system. After passing governance approval, a DevOps pipeline provisions the necessary compute, storage, and access to enable agile experimentation without manual delays. Once a model is ready, it's committed to Git, triggering a CI/CD process. Machine learning engineers harden, retrain, and publish the model to a centralized registry, deploying endpoints for downstream use. Automated monitoring detects model drift and retrains as needed, while ensuring security and auditability. However, it's important to note that this decentralized PaaS-based MLOps setup is not a unified SaaS analytics platform. Governance is fragmented with varied tools and standards across teams, leading to duplicated controls, increased risk, and inconsistent policies. Operational overhead is high due to manual environment setups and inconsistent pipelines, slowing development and increasing errors. Collaboration suffers from scattered toolchains and registries, causing silos and limited knowledge sharing. As the number of teams and models grow, the lack of standardization becomes a major bottleneck. In contrast, unified SaaS platforms like Microsoft Fabric or Databricks delivers centralized governance, security, and compliance uniformly across domains. They automate provisioning and enforce standardized CI/CD, speeding delivery and reducing errors. Integrated monitoring and lifecycle management ensures models remain accurate and available. Seamless self-service and collaboration empowers business users and data scientists to innovate within clear controls. And most importantly, Fabric scales effortlessly to support thousands of users and models without operational chaos. While decentralized PaaS MLOps addresses local automation needs, integrated SaaS platforms like Fabric and Databricks offer the combination of ease of use, agility, and enterprise discipline necessary for modern AI and analytics at scale. So it's quite clear that a unified data and analytics platform transforms how organizations manage and leverage data by consolidating storage, processing, security, and analytics into a single scalable environment. Let's look at some of the benefits of these unified data and analytics platforms. Scalable data storage and processing. So modern unified data platforms automatically scale to handle massive, rapidly growing data sets without bottlenecks. SaaS solutions offer flexible pay-as-you-go or reserved resource models, reducing costly hardware investments while delivering virtually unlimited cloud storage and decoupled compute capacity. This elasticity ensures that businesses can grow data volumes seamlessly without disruption. Number 2, rapid access and streamlined collaboration. By enabling real-time data sharing and integration across departments, vendors, and institutions, these platforms break down silos and foster collaboration. Access to standardized, well-documented data accelerates joint analysis and discovery, while easier interagency and public data sharing drives innovation across systems. Cost optimization and resource efficiency. Centralizing data management in the cloud significantly lowers upfront capital expenditures and reduces ongoing operational overhead. Built-in unified governance, security, and compliance handled by the platform provider minimizes manual effort and risk. SaaS and PaaS offerings also support consumption-based pricing, letting organizations pay for only what they use, maximizing ROI and minimizing waste. Enhanced security, compliance, and data governance. Modern unified platforms deliver robust automated security controls, traceability, and compliance features essential for federal and industry regulations. Improved auditability and data quality frameworks help ensure data integrity and resource adherence with less manual workload, protecting organizations against risks and penalties. Number 5. Accelerated research and innovation. Unified PaaS and SaaS platforms provide pre-configured tools and workflow automations for analytics, machine learning, and AI, dramatically shortening the experiment and development life cycles. Advanced analytics include deep learning and Gen AI, which can rapidly be deployed and scaled to new use cases, empowering agile innovation and faster realization of business value. Overall, unified platforms simplify complexity, boost agility, optimize cost, and unlock advanced analytics capabilities, enabling organizations to make faster, smarter, and more collaborative data-driven decisions in a scalable, secure environment. Before we dive into the benefits of modern unified platforms, it's helpful to take a quick look back at how Microsoft's data platforms evolved over the years. It all started more than 30 years ago with SQL Server's launch in 1989. Over time, it expanded through the business intelligence and big data phases, eventually leading us to today's cloud-first approach. Starting with on-premises infrastructure, organizations had full control over their data and systems, but this came with high costs, complexity of maintenance, and limited scalability. Then came infrastructure as a service, or IaaS, which moved hardware management to the cloud. This eliminated the overhead of physical servers and allowed flexible scaling. The catch? Users still needed to manage the operating system, middleware, and applications themselves. Next, platform as a service, or PaaS, abstracted away platform management entirely. Developers could focus on building and deploying applications quickly without worrying about managing the underlying infrastructure. However, organizations still had to build and maintain their own apps. Finally, software as a service, or SaaS, offers fully managed applications accessible over the internet. This reduces IT effort, provides centralized governance, and ensures easy scalability, although it offers less customization and control over the platform. Today, unified analytics platforms combine aspects of both PaaS and SaaS to deliver powerful, scalable, and governable solutions all in one place. Okay, now that we have a good understanding of some of the benefits of a modern unified data and analytics SaaS platform, let's look at an example of one of these platforms, which is Microsoft Fabric. So what is Microsoft Fabric? Well, Microsoft defines Microsoft Fabric as an end-to-end cloud-based analytics platform that unifies data movement, processing, storage, and visualization in a single SaaS solution. All workloads run on top of OneLake, a unified open data lake storage layer supporting Delta Lake format. It's important to remember that each Azure tenant gets one instance of a OneLake, and OneLake is basically an ADLS Gen 2 abstracted under the hood. For the compute engine, Microsoft Fabric powers data analytics, data science, and real-time workloads. It includes Apache Spark for data engineering, a distributed SQL engine for warehousing, and real-time intelligence tools like event streams and real-time hub for low latency data ingestion and streaming analytics. It also has a unified scheduler which allocates compute across services, enabling efficient processing over one lake with open formats like Delta Lake and Parquet. So let's go over some of these components. Data Factory, very similar to Azure's Data Factory, orchestrates and automates data integration pipelines, enabling seamless ELT workflows across diverse data sources within Fabric. From a data engineering perspective, the platform provides access to Spark compute engines, along with native Spark execution engines for big data processing, data engineering, and machine learning workloads. You will have access to notebooks, pipelines, and large-scale data transformations with extremely high efficiency. It also brings a lakehouse engine, which combines the flexibility of data lakes with the management and performance of data warehouses. The data is typically stored in Delta Lake format for analytics and machine learning, enabling both SQL and Spark-based processing. For data science, you'll have notebooks and fully managed Apache Spark environments for scalable data exploration, preparation, and machine learning, supporting Python, Scala, R, with advanced features like native execution engines for accelerated analytics and seamless integration with OneLake. From a data warehousing perspective, you'll have access to scalable, high-performance SQL analytics over structured data. This can support enterprise data warehousing scenarios with features like T-SQL support and advanced security. From a real-time intelligence perspective, you'll be able to handle real-time data ingestion and processing from sources like IoT devices, applications, and logs. Support for streaming analytics and event-driven architectures for instant insights. You'll also have Event House, which is optimized for high-volume, real-time event data storage and analytics, which enables fast querying and aggregations of streaming event data for operational intelligence. From a reporting perspective, you'll be able to integrate all of these components seamlessly into Power BI to deliver interactive data visualizations and BI capabilities. You'll be able to enable users to build and share dashboards and reports directly on top of OneLake data with Direct Lake and also PBIP for version control and integration with deployment pipelines. From a monitoring perspective and alerting, you'll have Data Activator, which is a no-code automation engine for data observability and triggering actions based on data changes or anomalies. Mirroring is another neat capability which offers near real-time replication for seamless replication of operational data from databases and warehouses into OneLake for your analytics. It brings low latency, low cost, and really eliminates the need for complex ETL, providing a turnkey, fully managed solution for continuous data integration. The platform is secure and flexible to support sources behind firewalls and offers granular control on what's mirrored. It's analytics ready, so mirrored data is stored as Delta tables, instantly available for Spark, SQL, and Power BI workloads. You'll also have access to shortcuts, which are virtual data access pointers to external data sources like Azure Data Lake Storage or Databricks, Unity catalogs, so on and so forth, so it appears in OneLake without duplicating or moving files. This brings real-time updates, so changes in source systems are immediately reflected in Fabric, ensuring users always work with the latest data at all times. So it's truly unified analytics, enabling seamless querying and analysis across multiple data sources as if all the data resides in one lake. When it comes to managing Microsoft Fabric, it's essential to understand the different levels of administration that keep the platform secure, efficient, and collaborative. Let's walk through the hierarchy together, highlighting how each layer plays a distinct role, right down to the finest details. At the very top, we have the tenant level administration. This is the governance layer that spans the entire organization. Here, roles like the global administrator and Fabric administrator have broad oversight. They set the policies that affect every domain and workspace, manage user access and security, and ensure compliance is never an afterthought. Think of this as laying the foundation for how your entire organization interacts with Fabric. Moving down, we reach capacity level administration. Capacities are dedicated pools of resources, compute and storage, from which different business units or workloads can draw. The capacity admin's job is to allocate these resources, assign workspaces appropriately to capacities, and fine-tune performance, making sure that each business line operates smoothly and efficiently without stepping on each other's toes. Next is domain-level administration, which is especially relevant in organizations embracing a data mesh approach. Domains group related workspaces, often by business unit like finance or marketing. Domain admins and contributors tailor governance, adjust metadata, and assign workspaces ownership, all within the scope of their domain. This empowers business units with autonomy to manage their own data while still operating inside the organization-wide guardrails. Drilling further down, we come to the workspace level administration. Here, workspaces act as containers for key data assets, datasets, reports, dashboards, you name it. Workspace admins and their teams make sure that each area of work has the right access, assigning roles and managing permissions, that collaboration happens securely and efficiently. This is where project teams get the control they need to build, analyze, and share insights. But administration in Fabric doesn't just stop at the workspace. For more granular control, we have object and file level administration. This lets organizations specify access to individual reports, tables, or files, providing targeted protection and flexibility for sensitive assets. And finally, at the deepest level, we come to row and column level administration. This is where security policies can be applied directly to the data itself, limiting what information different users can see right down to specific columns or rows in a table. When these levels work together, organizations get a framework that is both robust and adaptable. You maintain enterprise-level governance while also empowering domains and teams right down to safeguarding every data point. This layered approach is at the heart of secure, scalable, and innovative work in Microsoft Fabric. I want to introduce you to how Microsoft Fabric implements the data mesh paradigm to empower domain-oriented, self-service data ownership while ensuring enterprise-grade governance and scalability. At its core, a data mesh decentralizes data ownership and treats data as a product owned by domain teams. Microsoft Fabric enables this by organizing resources into domains and workspaces within a unified SaaS environment. Let's break down the architecture and how this approach works in practice. The platform runs within an Azure tenant configured with secondary region failover for high availability and disaster recovery. It leverages two Fabric capacities, an F5064 for development and an F128 for production, with paired region replication to ensure business continuity. Storage is maintained through a single tenant level 1 lake, providing zone and locally redundant storage for durability and readability. Now here's where the modern automation and governance shine. When users need a new workspace or domain environment, The process starts with a service request, typically submitted through commonly used IT service platforms like Jira or ServiceNow. This request then moves through an approval workflow, ensuring proper oversight and compliance with organizational policies. Once approved, the system triggers an automated DevOps pipeline built into Microsoft Fabric and integrated within Azure DevOps, which then creates the requested workspace or domain environment in the Fabric capacity, complete with the appropriate permissions and configurations at both the workspace and domain levels. This automation can also be managed manually if needed, but the goal is really to enable fast, governed, self-service provisioning. From the data mesh paradigm perspective, this empowers teams to have product-based ownership at the domain and workspace level, the finest granularity where real business value is generated. Within these domains, data scientists and machine learning teams build and manage their ML models. Data engineers maintain data ingestion, transformation pipelines, and enterprise data warehouse modeled with dimensional star schemas. Business analytics teams work within their own workspaces, often aligned to domains such as revenue or marketing, to create semantic models, Power BI reports, and data sets, utilizing source control and continuous integration and continuous deployment pipelines. This approach balances business domain expert empowerment with technical oversight and agility using DevOps best practices. The domain teams typically include analysts, analytics engineers, and Power BI developer roles that apply software engineering principles to ensure quality, repeatability, and governance. Finally, once the artifacts are approved through these pipelines, they're deployed to production environments accessible to business users, ensuring enterprise security, compliance, and governance are maintained throughout. This combination of ticket-based environment request workflows, approvals, automated DevOps provisioning, and domain-level ownership exemplifies how Microsoft Fabric's data mesh implementation delivers scalability, agility, and strong governance simultaneously. Let's walk through the critical phases of a successful migration plan, covering everything from leadership buy-in to change management that drives a smooth and well-governed transition to Microsoft Fabric or any modern unified data platform. Number 1, executive sponsor buy-in. This is the first crucial step. Securing leadership approval means not only getting the budget, but also gaining committed sponsors and setting the governance groundwork. We present a compelling business case with clear ROI and project goals to ensure alignment at the highest level. The outcome is an approved project charter, clear sponsor roles, and a structured communication plan to keep all stakeholders engaged. Number 2, enterprise architecture assessment. Before diving into implementation, we need to thoroughly understand the current landscape. This means analyzing existing systems, data flows, and technologies to identify gaps and risks. Mapping dependencies helps us select the right enterprise architecture framework that fits organizational needs. Deliverables here include detailed architecture documents, a gap and risk report, and a strategic migration plan. Number 3, planning the proof of concept. Next, we define the POC scope, choosing target workloads and setting success criteria. A cross-functional team is assembled and technical architecture is detailed. This phase is about laying a clear, actionable plan for the POC and ensuring stakeholders are aligned. Key deliverables are the scoped project plan, success metrics, and a communication strategy for engagement. Number 4, implementing the POC. With planning complete, the POC environment is built on Fabric. Selected data and workloads are migrated, and integration, performance, and governance tests are conducted. Feedback from users helps us analyze outcomes and refine the approach. Deliverables include an operational POC environment, comprehensive test reports, and documented lessons learned. Number 5. Scaling the platform through phased migration plans. Based on the POC insights, a phased migration roadmap is created. We prioritize domains by business value and technical complexity, form migration teams, and plan resource allocation, timelines, and governance updates carefully. Deliverables include the complete migration roadmap, resource planning documents, detailed workflows, and updated governance policies to support scale and control. Number 6. Eliminating technical debt from underperforming systems. Parallel to scaling, we systematically identify legacy systems, redundant code, and manual processes that slow progress. Plans are made to decommission or refactor these components while maintaining data quality and security during transitions. Deliverables include a technical debt inventory, refactoring and decommissioning plans, and updated system documentation. Number 7. Testing. Rigorous testing ensures reliability. Unit tests, integration tests, system validation, and user acceptance testing confirm that data integrity, performance, and compliance standards are met. Detected defects are resolved and formal sign-offs obtained before moving forward. Deliverables include detailed test plans and scripts, execution reports, default logs, and final UAT sign-offs. Number 8. Training. Effective adoption depends on empowering users and admins. Role-based training programs are developed and delivered, including documentation, hands-on sessions, and ongoing support channels. Feedback is gathered to refine training and plan continuous education. Deliverables encompass training materials, session attendance records, and feedback reports. And finally, number 9, change management. Finally, we drive organizational adoption by communicating the migration benefits, timelines, and impacts regularly. Change champions are engaged to help manage resistance, and feedback loops keep adjustments responsive. Continuous support and adoption tracking ensure the platform's successful use over time. Deliverables include the change management strategy, engagement documentation, adoption metrics, and ongoing feedback reports. Choosing the right unified data and analytics platform really comes down to your organization's priorities, existing investments, and how you want to balance ease of use with flexibility and advanced capabilities. Let's start with Microsoft Fabric. Choose Fabric if your organization wants a fully managed SaaS analytics platform that takes care of infrastructure for you. It's a natural choice if you've already deeply invested in Power BI or the broader Microsoft ecosystem. Fabric excels when centralized governance, user-friendly administrative experiences, and seamless business intelligence integration are top of mind. You also benefit from built-in security, compliance, and plenty of no-code, low-code data engineering options, making it especially approachable for teams that want to move quickly without relying heavily on deep engineering expertise. Now, on the other hand, Databricks shines for organizations that crave advanced data engineering and machine learning power. It's really the better fit if your team values open source extensibility, enterprise scale workloads, and mature collaborative notebooks. Databricks supports multi-cloud and hybrid deployments, offering flexibility when you need to operate across cloud providers or on-premises infrastructures. It's also ideal if you require fine-tuned control such as granular resource isolation, dedicated clusters for ML and AI use cases, and seamless integration with a wide array of open source tools and automation frameworks. Ultimately, it's all about aligning the platform to your team's skills, organizational investments, and the specific data workloads you want to power. Choosing the right cloud data warehouse is about matching your organization's priority, be it technology ecosystem, analytics sophistication, or operational flexibility, to the distinct strengths of today's leading platforms. Choose Fabric Data Warehouse if you need the deepest integration with Microsoft Azure and Power BI, making Fabric ideal for organizations already invested in the Microsoft stack. Fabric uniquely delivers an end-to-end SaaS experience, combining data warehousing, business intelligence, and AI services into a single unified environment. This simplifies onboarding, centralizes governance, and provides exceptional accessibility for business users and analysts, especially those seeking rapid project launches with low-code, no-code data engineering. Fabric also excels if you require strong T-SQL support, native Microsoft data governance, and smooth connectivity to your broader Azure data estate, including OneLake, storage, data factory, ML, and Synapse integration. Fabric excels at operational and real-time reporting through familiar Microsoft tools and offers straightforward consumption-based pricing designed for Azure-centric organizations. Choose Snowflake if multi-cloud support is a must, because Snowflake operates seamlessly across AWS, Azure, and GCP. It's also great if your primary need is high concurrency, structured SQL analytics at scale, with automatic scaling, fast performance, and secure zero-copy data sharing. Snowflake stands out for robust RBAC, compliance, and operational simplicity, offering true SaaS with minimal infrastructure management, flexible pay-as-you-go pricing, and a wide marketplace for external data sharing. It's particularly well suited for organizations that want structured analytics accessible to both advanced analysts and business users using a familiar and powerful SQL interface. Choose Databricks SQL Data Warehouse if your focus is on big data engineering, advanced analytics, AI ML, and you really want to leverage the powerful Apache Spark engine. Databricks SQL shines if you really want to handle streaming and batch analytics, unstructured, semi-structured data, or require deep integration with open source data science and ML frameworks. Databricks SQL Warehouse supports fine-tuned resource control, custom Spark clusters, and high concurrency, ideal for organizations with sizable engineering teams and complex analytics workflows. So choose Databricks if you need code-first deployment, strong notebook experience, or hybrid multi-cloud flexibility for both analytics and AI. Databricks' unified data intelligence platform is built on the modern medallion lakehouse paradigm, which ensures reliable data layering and quality using the powerful Databricks first architecture. It supports a hybrid PaaS environment, integrating services like Azure Data Factory, ADLS Gen 2, and SQL Managed Instance with SaaS capabilities for flexible data workflows. Security and network control are top priorities, with highly customized infrastructure, including managed private endpoints and virtual networks to safeguard data and meet compliance needs. At the core, Databricks unifies critical platform resources such as Data Factory, ADLS Gen 2, Purview for data governance, Azure DevOps for deployment, and Unity Catalog for metadata management and governance, providing seamless compute and storage orchestration. Together, these elements deliver a secure, scalable, and fully managed platform that empowers data engineers, scientists, and analysts to collaborate, innovate, and accelerate analytics from data ingestion through AI-driven insights. Modern unified data and analytics platforms combine the best of cloud-native SaaS with hybrid PaaS tools to deliver scalable, flexible, and governed data capabilities. First, A hybrid PaaS foundation integrates services like Azure Data Factory for orchestration, Azure Data Lake Storage Gen 2 for scalable data lakes, SQL Managed Instance perhaps for relational processing, all complemented by Microsoft Fabric's SaaS workloads. This blend enables seamless data ingestion, transformation, storage, and analytics within a unified environment. The platform leverages a Lambda architecture to manage data through both streaming and batch layers, providing robust, low-latency real-time insights alongside comprehensive historical analytics. Streaming pipelines handle real-time event and telemetry, while batch processes ensure thorough, repeatable data refinements and aggregations. This dual approach is enhanced by Fabric's native integration of streaming capabilities and batch processing workloads, enabling fast, incremental data updates. Finally, deployment pipelines enforce multi-environment workflows, development, testing, production, with automated CI/CD tooling that streamlines environments, provisioning, artifact promotion, and governance compliance. This ensures agility and operational rigor across the data lifecycle. Together, these core elements deliver a modern, scalable, and secure unified and data analytics platform that empowers diverse teams to collaborate, innovate, and drive timely data-driven decisions. In this section, I'll go over the top 5 lessons learned from implementing Fabric. Effective capacity planning in Microsoft Fabric begins by benchmarking current workloads, whether it's on-premises or cloud, using tools like the Fabric Capacity Estimator. This ensures that you right-size capacity to balance performance and cost, avoiding over or under provisioning. Regular reviews and adjustments of capacity as usage evolves is critical. Note that the F-SKU don't support auto-scaling like P-SKUs, and Copilot was initially available only on F64 and higher SKUs. So there's quite a few nuances to keep in mind. Understanding these limitations prevents surprises. For cost savings, purchase premium reserved instances, especially F-SKUs, which offer up to a 30% discount compared to pay-as-you-go pricing. This is ideal for predictable workloads and helps budget better. Designing Microsoft Fabric workspaces efficiently is critical to enabling scalable, manageable, and secure data environments aligned with business goals. First, structure your workspaces by domain or department to reflect business functions and support domain-based data product ownership aligned with the data mesh paradigm. This ensures clarity around ownership, accountability, and accelerates domain-level innovation. Second, be mindful that once workspaces are created, migrating to a different structure is complex and time-consuming. It often introduces redundancies in reporting and data sets, so early collaboration and deep partnership with business stakeholders is essential to getting the design right from the beginning. Third, to deliver targeted content securely to different user groups, leverage Power BI apps with audience targeting. Since each workspace supports only one Power BI app, this limitation must be factored into your workspace design to optimize content distribution and access management. Finally, standardize workspace naming conventions, access controls, and governance practices. This standardization is crucial for scaling your deployment, maintaining clarity across teams, and enforcing consistent security and compliance policies. In summary, efficient workspace design in Microsoft Fabric balances domain alignment, stakeholder collaboration, secure targeted content delivery, and disciplined governance to build a scalable, clear, and secure data environment. In Microsoft Fabric, successful platform management relies on a suite of powerful tools and clear governance to ensure security, efficiency, and scalability. The Capacity Metrics app helps monitor resource usage, spot trends, and proactively manage capacity. Clear admin roles assign responsibilities to maintain secure and organized administration, while the admin portal provides a centralized dashboard for seamless oversight and quick issue resolution. Robust permission levels offer granular control across multiple layers, from tenant and capacity to domain, workspace, individual items like files, and even row and column levels, ensuring precise data security. Equally important are Fabric's governance tools, like sensitivity labels and endorsements, which help classify data, enforce policies consistently, and promote trusted, high-quality content across the organization. By effectively combining these tools with disciplined governance practices, organizations can build a secure, compliant, and well-managed Fabric environment that scales with confidence and supports trusted analytics. Microsoft Fabric offers a robust suite of native features designed to optimize performance across its analytics ecosystem, from Power BI to Lakehouse and Spark environments. Starting with Power BI, Direct Lake enables live reporting on Lakehouse data without the need for data movement, ensuring real-time insights. XMLA endpoints provide enterprise-grade connectivity and automation capabilities, allowing seamless integration with enterprise tools for dataset and model management. The use of PBIT and PBIP file formats facilitates easy sharing, version control, and consistent deployment of Power BI projects and templates. Additionally, Semantic Link orchestrates and monitors semantic model refreshes programmatically, automating dependency tracking and streamlining workflows to reduce manual effort and improve refresh performance and system responsiveness. In the warehouse, automatic partitioning optimizes data storage and query efficiency with minimal manual tuning, while resource optimization dynamically manages compute capacity to deliver cost-effective analytics at scale. For the Lakehouse, smart caching accelerates query speed on frequently accessed datasets. Shortcuts simplify dataset accessibility by virtually linking data across workspaces, and mirroring ensures high availability and near real-time data synchronization for operational workloads. When it comes to Spark, Fabric supports high concurrency for many parallel users and jobs, and dynamic allocation automatically scales resources to handle workload spikes. Custom environments and custom Spark pools provide tailored runtime configurations and dedicated resources to meet diverse analytics and machine learning demands. Finally, the native execution engine boosts backend data processing on Lakehouse infrastructure, delivering up to 4 times faster query execution at no additional cost. Combined, these features enable Fabric users to achieve high performance, scalability, and efficient resource use across analytics workspaces and workloads, ensuring fast, reliable, and cost-effective data insights. As with any evolving analytics platform, it's essential to stay aware of current limitations in Microsoft Fabric, especially when using features in public preview or those under rapid development. These preview features can offer early access to cutting-edge capabilities, but may change or present unforeseen gaps. Before rolling out Fabric solutions into production, thoroughly test critical workloads and integrations in your environment. This proactive approach helps identify any gaps, reliability issues, or workarounds you might need, minimizing downstream surprises and business risks. Finally, actively engage with Microsoft's product roadmap and community forums. Staying connected helps you anticipate feature updates, plan for changes, and align your deployment strategy with the latest platform direction. This ongoing engagement ensures you're ready to adapt quickly as the platform matures and new limitations or capabilities emerge. In summary, a disciplined approach, staying informed, testing thoroughly, and engaging with Microsoft roadmap will help you navigate Fabric's evolving feature set and drive successful, future-proof implementations. Today's traditional data platforms are mostly passive. You build them and hope users engage with insights. Microsoft Fabric changes this with generative AI, Copilot, and AI agents that are proactive, so they monitor, act, recommend, and even communicate automatically. First, Fabric accelerates developer productivity by using generative AI to write code instantly and intelligent agents that monitor pipelines in real time. These agents catch errors or inefficiencies that can fix issues automatically, minimizing downtime and letting developers focus on high-value work. Second, conversational AI democratizes business intelligence. Tools like executive summarizers generate clear, concise reports, and users can ask for custom Power BI insights with natural language, making analytics accessible without technical skills. Third, intelligent feedback agents analyze customer and operational data at scale. GenAI-driven tools listen to calls, extract sentiment, summarize reviews, and provide real-time coaching, boosting service quality and continuous improvement. Lastly, AI-driven data enrichment and anomaly detection are built into workflows, from scanning images for defects to real-time anomaly alerts and automatic remediation. Fabric embeds intelligence throughout the data lifecycle to ensure quality and operational health as data scales. This combination fundamentally transforms data platforms from passive repositories into intelligent, autonomous systems that drive faster, smarter business outcomes. Today, teams need instant, tailored insights from their enterprise data, not just generic answers. Intelligent, domain-specific copilots make this possible, acting as a smart assistant that understands the unique needs of each business area. This solution leverages powerful Azure AI services to create intelligent, domain-specific copilots that deliver fast, relevant, and human-like responses from enterprise documents using a retrieval-augmented generation RAG workflow. Here's how it works. Users interact with a chatbot hosted on an Azure web app, sending queries that are securely processed through managed identity. The queries are forwarded to Azure AI Search, which organizes and retrieves the most relevant information by matching the meaning of the query with indexed documents using OpenAI generated embeddings. These relevant passages are combined with the user query and passed to the OpenAI GPT-4o LLM model, which generates clear, context-aware, and accurate responses. The chatbot then delivers these answers back to the users instantly. All components are managed via Azure AI Studio, providing a secure, scalable platform to handle data indexing, embeddings, and AI model operations. By integrating fast semantic search with advanced natural language generation, this approach empowers organizations to build intelligence, role-specific copilots that help business teams explore data and gain insights effortlessly. Generating comprehensive documentation for thousands of Power BI measures across hundreds of reports can be daunting and manual. Microsoft Fabric Semantic Link, combined with Power BI and OpenAI, transforms this process into an automated, scalable solution. Using Fabric Semantic Link, we automatically extract metadata directly from datasets, including complex DAX measures. OpenAI then converts these intricate formulas and calculations into clear natural language expressions that are easy for business users to understand. This automated documentation can be seamlessly integrated into DevOps pipelines, allowing teams to review and govern content before publishing. This ensures both accuracy and compliance with organizational standards. Finally, the up-to-date documentation is embedded directly into Power BI reports, enhancing user comprehension and empowering stakeholders to make data-driven decisions with confidence. Together, This approach eliminates tedious manual documentation efforts, improves transparency, and drives greater adoption of Power BI insights across the organization.